Hello, geometry students. This is Mr. Zacek with you. My voice is a little weak today. Had a little cold, so I'm gonna be a little more low key than normal. We are here in Unit 4, Lesson 7, and we're talking about overlapping triangles. And I'm actually going to kind of skip these first two things here. Those are not the core of what we're going to do today, but we're going to start here on this page. And so sometimes congruent corresponding parts of one pair of congruent triangles can be used to prove another pair of triangles congruent. And this often involves overlapping triangles. So overlapping triangles may have a common side or angle, and we can simplify your work by separating and redrawing the triangles. So this is the key strategy right here. You can simplify your work with redrawing those. So this is going to be kind of the strategy that we'll use to help this. So what common angles do triangle ACD and triangle ECB share? Well, if we draw these, so this is ACD, and this here would be, I kind of try to draw them like they're, like I see them in the picture, BCE. And what we should notice here is that angle C is the same angle in both triangles. So we could say that angle C is congruent to angle C by the reflexive property. Okay, so if we were doing a proof, we could use those. So sometimes we have overlapping or common angle that is shared, and so we can use that in a proof because it is the same part. All right, now what is the common side? So if I were to take a highlighter here and highlight these two triangles, ABD would be this triangle, and BAC would be this triangle, and we see the part there that overlaps. Now I'm going to draw them separately because that's the strategy that I recommend you use as we go through this. So BAC and BAD. So the common side here is side BA. So BA is congruent to BA, and again, that's by the reflexive property. So those are the two type of things that we can get with, they're kind of freebies that we get with overlapping triangles, but it looks, just a little bit different here. So I think we've got 3 proofs here just to practice some of this, give you an idea of what we're doing here. So in this example, we're trying to prove that SP is congruent to TP. Now sometimes you get multiple triangles here, and if we look at this, we've got a whole bunch of pairs of triangles. So what I'm going to start with is I'm going to start with identifying what I'm trying to prove, and that's SP and TP. When I see that, I realize that those are some overlapping triangles, and the overlapping triangles that are there are SUP and RPT. So always draw first, and what we see when we draw is that they share that common angle of angle P, which would be here in this example. All right, and then in addition to that, we're given the angle PSU. So this angle is congruent to angle PTR. That's this angle. And side SU is congruent to side TR. So we've got 2 angles and a side, and the side is not included. So we can prove the triangles by angle, angle, side, and then that would give us the parts by CPCTC. Corresponding parts of congruent triangles are congruent. All right, so not a lot of steps. We can say angle PSU congruent to angle PTR, and then side SU is congruent to side TR. So that's given. All right. And then we have our common angle, which is angle P is congruent to angle P by the reflexive property. And then the last part of this is that we have the triangles. Well, excuse me, not the last part. We could say triangle PSU is congruent to triangle PTR. And the reason for that would be angle, angle, side congruent to angle, angle, side. And then as a result of that, we could say that side SP is congruent to side TP because corresponding parts of congruent triangles are congruent. Okay. So moving on. AD is congruent to AE, and angle ACD, and we're trying to prove that triangle ABC is isosceles. So we kind of begin with the end in mind. I'm trying to prove that this big triangle is isosceles. Well, if that were the case, what I would need to show is something like side AB is congruent to side AC. So if that were the case, that would get me to isosceles. So I notice that those triangles, if I were to draw them separately, A, E, B, and triangle ADC, those have the two sides. So let's see. Again, there's a whole lot of overlapping triangles here. So that's why I say begin with the end in mind. And let's see if this works. Well, what we know from this is that these angles are the common angles. That's the overlapping part. Then we have AD congruent to AE. And then we have angle ACD congruent to angle ABE here and here. So those two triangles would be congruent by, again, angle, angle, side, which gets us to the parts, CPC, TC, which gets us to it being an isosceles triangle. So, sometimes when I do this one, I might draw these ones down here. Well, those would be the wrong, those ones are also overlapping. They have a common side, but actually there is a way you could use those ones to prove it, but let's go with the one that we already started. So AD is congruent to AE, and angle ACD is congruent to angle ABE. That is given. Okay, so now what else did we need to prove the triangle is congruent? That angle A is congruent to angle A, and that's true by the reflexive property. It's the same angle. So this is our side congruent to a side, angle congruent to an angle, angle congruent to an angle. So therefore the triangles are congruent. So triangle ACD is congruent to triangle ABE, and that's by angle, angle, side congruent to angle, angle, side. Okay, so again, I'm looking at that big triangle and I'm realizing that what I wanted to show was that this side AB and AC are going to be congruent. Well, the nice thing is those are parts of the two triangles. So we've got AB congruent to AC, and that's corresponding parts of congruent triangles are congruent, and therefore triangle ABC is isosceles. So the reason is if two sides of a triangle are congruent, then it is isosceles. If two sides of a triangle are congruent, then it is isosceles. Okay, So these proofs are really challenging our, kind of basic understanding. So, if we've done a good job earlier in the unit of getting understanding for how to do kind of the triangle proofs, it allows us to build on with these other parts. If we're still struggling with that point, we've got some questions to ask and some hard work to do to gain that understanding. Okay, last one is we're trying to prove that QPT, so I'm going to use my highlighter here. So triangle QPT is congruent to triangle QRT, and let's see what we're given. That seems pretty straightforward. So we're given that PS over here is congruent to RS over here, and then we're given that PSQ, this angle is congruent to this angle here, RQS. So over here, those two angles. All right. So PS is congruent to RS. Whoops, I marked that wrong. That's part of why I'm having confusion. Highlight, let's go back. Okay, PS is congruent to RS. And so what we're going to do in this case is we're going to prove first that here's what I could prove. I don't want the green. I'm going to change my highlighter to a yellow highlighter. We can prove this triangle here is congruent to this triangle, okay, by side angle side. So I'm going to go ahead and just sort of start this out. So PS is congruent to RS, and angle PSQ is congruent to angle RSQ. All of that's given. Now, if you look at my yellow triangles, the other side that's missing from those, the common side, is QS is congruent to QS. All right, and that is by the reflexive property. So they have a common side, a shared side. So what can we say? Well, we can say now that triangle PSQ is congruent to triangle RSQ, and the reason for that is side angle side congruent to side angle side. Okay, now I'm going to use a different color to show us what we have here. At this point, PQ and QR are kind of common by CP/CTC. We can do that. So PQ is going to be congruent to QR, because again, I'm trying to prove the green triangle is congruent. So corresponding parts of congruent triangles are congruent. In addition, this angle and this angle are also congruent to each other because they're corresponding parts. So we could say angle PQT is congruent to angle RQT, and the reason for that would be corresponding parts of congruent triangles are congruent. Now, what are we missing? Well, that side right there, which is QT. So we could say that QT is congruent to QT by the reflexive property. And at that point, now we've got enough for side angle side from those two triangles. So this would be triangle QPT congruent to triangle RQT by side angle side congruent to side angle side. So the idea here is we had to use one triangle that we could to get the parts to prove another triangle. So we're getting into, some real higher level proof things that require just kind of a way of thinking through this systematically. Okay, challenging stuff here with it, but stuff that we're capable of doing as well, even though it's hard. We just have to follow the rules as we go through it. All right, good luck with this. We've got some big labs coming up that are going to be reviews, and then a quiz to finish out this unit on triangle proofs.